On October the 17th, a NASA official revealed during a meeting of the Astrophysics Advisory Committee that the European Space Agency had begun exploring options and studying the feasibility of launching the Euclid Near-Infrared Space Telescope on SpaceX's Falcon 9 rocket. By mid-2023, another Falcon 9 rocket will launch the Euclid Telescope into deep space. Welcome to Tech Heaven, and in this video we'll take a look at SpaceX launching Europe's next deep space telescope and first asteroid orbiter. After all domestic alternatives failed, director Josef Aschbacher confirmed less than 3 days later that ESA will contract with SpaceX to launch the Euclid Telescope and Hera, a multi-spacecraft mission to a near-Earth asteroid. The European Union, and by extension ESA, are notoriously insular and parochial when it comes to rocket launch services. That attitude was largely shaped by ESA and the French company Arianespace's success in the international commercial launch market in the 1980s, 1990s and 2000s, a hard-won position that all parties seem to take for granted at some point. When that golden era collided with SpaceX's brick wall in the mid-2010s, Arianespace faced a truly threatening competitor for the first time in 15 years. More importantly, ESA and the European Union had little influence over SpaceX and could do little to prevent the private company from quickly becoming the international launch industry leader. ESA, European Union, and Ariane officials, like the traditional US launch industry that SpaceX aggressively disrupted, remained in denial well into the late 2010s, even as SpaceX devoured their market share. When the European Space Agency and Arianespace began work on a rocket to replace their highly successful and once competitive Ariane 5 in the early and mid-2010s, they ignored SpaceX's loud pursuit of affordable launches via reusable rockets. European stakeholders eventually decided to create a fully disposable successor, Ariane 6, by simply tweaking the ingredients of the proven Ariane 5 formula. However, despite taking the path of least resistance in 2014, Ariane 6's launch debut has been pushed back from 2020 to late 2023 at the very least, causing havoc for many of the commercial and institutional European payloads assigned to the rocket over the years. Then, in February 2022, Russia illegally invaded Ukraine for the second time, causing havoc throughout Europe. In response to widespread European criticism, Russia took a batch of US-built, British-owned OneWeb satellites hostage, stole the Soyuz rocket they had already purchased, and reneged on a launch deal, costing the company hundreds of millions of dollars. They also officially withdrew from all partnerships with ESA and Arianespace, effectively ending the practice of Europeanized Soyuz launches and leaving a number of joint missions stranded or in limbo. One such mission was Euclid. The small near-infrared space telescope's development began in the early 2010s and was estimated to cost more than 1 billion euros in 2013. At the time, Euclid was set to be launched by a European Soyuz 2.1 rocket to the Sun-Earth system's L2 Lagrange point as early as 2020. By the way, if you're watching us for the first time, make sure to hit that subscribe button and turn on notifications so you can enjoy our future videos while getting updated. Getting back to the topic. After Russia's second invasion of Ukraine eliminated Soyuz as a viable option, ESA briefly stated that Euclid would instead be launched on Ariane 6. ESA announced in October 2022 that the launch of Ariane 6 would be pushed back from its current target of late 2022 to late 2023 or even early 2024. As a result, 13 satellites, the majority of which are European, face 6, 12 or even 18+ months of guaranteed launch delays. Less than 24 hours after announcing the latest major Ariane 6 delay, ESA's director revealed that 2 of the 13 satellites were already being transferred to SpaceX Falcon 9 rockets. Given that Euclid was orphaned by a Russian rocket, it's not surprising that the telescope's launch was transferred from Arianespace to SpaceX. The simultaneous announcement that Hera would follow suit, on the other hand, was far more shocking. Hera was always intended to be one of the first payloads launched by Ariane 64 rocket, equipped with a new Asterisk kick stage under development at Arianespace. If Hera had continued with the first 3-stage Ariane 6 after the 2-stage version's latest delay, the chances of missing the 17-day October 2024 window would have increased significantly. If Hera misses that brief window, orbital mechanics will result in backup opportunities in 2025 and 2026, extending the mission's cruise phase from 2 to more than 5 years. The primary goal of the €290 million Hera mission is to enter orbit around the near-Earth asteroid Didymos and study a new impact crater on its moon, Dimorphos. That crater is new because it was purposefully formed when NASA's DART spacecraft collided with the asteroid moon last month. SpaceX launched DART to Dimorphos on Falcon 9 rocket, and Hera will follow in its footsteps as early as October 2024. The primary goal of planetary defense is to protect humanity's home planet from asteroids, which have routinely caused mass extinction events throughout Earth's multi-billion-year history. DART is the first attempt to test and verify what appears to be the simplest and most obvious method of redirecting asteroids, knocking them off course with the spacecraft itself with the technology to detect and reach virtually all near-Earth objects more or less at hand. However, because planetary science and the behavior of things in microgravity conditions have a tendency to defy expectations, testing that assumption is critical. Instead of hitting any old NEO, DART lead investigator Andy Chang had an epiphany mid-exercise. A small spacecraft could slam into a tiny asteroid moon of a much larger parent asteroid. Hitting an asteroid moon would reduce the small but non-zero chance of accidentally redirecting the target towards Earth while also amplifying the results, making them much easier to observe from tens of millions of kilometers away. Instead of having to search for a nearly imperceptible change in a single asteroid's half-billion-kilometer-long orbit, the results of hitting the right asteroid moon would be much more easily detectable as a change in the moon's much smaller orbit around its untouched parent asteroid. The problem is that aside from spectrographic readings that reveal the broad strokes of an asteroid's composition and other telescope images that reveal the rough shape, scouting the objects without actually visiting them is extremely difficult. Given the difficulty, spacecraft have only visited a small number of our solar system's countless asteroids. It's difficult to predict what a spacecraft will do if it doesn't know what the surface and subsurface of a target asteroid are like. A looser surface, as most visited asteroids appear to have, would be much worse at transferring momentum than a boulder or relatively solid rock surface. As DART approached and revealed more detailed views of the surface of Didymos and Dimorphos in its final minutes, Chang was surprised to see how rough and boulder-strewn the asteroid surfaces were. Following the spacecraft impact, many scientists were surprised to see a massive cloud of dust ejected from Dimorphos, which was easily visible from ground-based telescopes. Despite the DART spacecraft's tragic demise, the fun on Earth has only just begun as scientists attempt to solve the riddle and begin looking for changes in Dimorphos' orbit. Data from even larger and more prestigious observatories such as NASA's Hubble and Webb Space Telescopes will be arriving soon. LICIACube, an Italian companion CubeSat that launched from DART shortly before impact, will also downlink images it captured up close, potentially providing the most detailed view of the impact in years. Meanwhile, the European Space Agency is working on Hera, a spacecraft that will launch in 2024 and attempt to enter orbit around Didymos and Dimorphos as early as late 2026 to investigate the aftermath of DART's last stand in greater detail. In the distant future, especially if the international scientific community eventually concludes that DART did successfully redirect an asteroid, the mission could help to kickstart an entirely new global project and fleet of spacecraft that will stand ready to protect Earth if the need ever truly arises. With a little luck and a small amount of government funding, humanity will be able to completely eradicate one of the most infamous causes of mass extinction in the near future. And with that being said, it's time to end our video, but before that, would like to know whether you're excited for Europe's next deep space telescope. Let us know in the comments. Like this video and make sure to subscribe to the channel for more amazing videos like this. We'll see you in the next video.